So we are going to discuss today about the NAT. NAT is basically network address translation. How it works, what is that, what is the benefit of it, why we use it. So all things we are going to discuss, and also at the same time we are going to discuss about how it works and what things we need to configure. So before discussing all that things, let's see here one thing that there are basically two type of IP address. IP addresses are basically two types. One is your private IP address and one is your public IP. Okay, so private IP and the public IP. So how to find out that which IP is the private and which IP is the public? It's very easy if you know about the private IP. The other rest will be the public. So there are three range of private IP address that you have to keep in your mind. If any IP starting with number 10 in decimal and the last three octet XX means I don't care. It can be any number from 1 to 255. So if any IP starting with 10, it will be a private IP. If any IP address is starting with 172.16.31 and in the last two octet anything, that will be also a private IP. The last, if IP is starting with 192.168.x, that will be also a private. So these are the only three private IP address range we have, and all the rest are the public. What is the benefit of having the private IP address? It's basically a free. We don't have to pay anyone on to ISP or anyone on the internet. No way. You don't have to pay any. It's totally free. You can use it in your network, and 100% you can communicate with each other. Like here, if I configure a private IP on my inside network, each and every device in the network can communicate. They can exchange the data, whatever they want. They can do it. No problem at all. The rules and all the things will be IP/TCP protocol will be the same. No problem. The only problem here with the private IP address that no internet access. You will never get the internet access by the private IP. Once you will reach on the ISP, ISP is going to drop the packet because private IP address is not allowed on the internet. So no internet access, but it's a free, so you can use in a private network and you can have a free communication. You don't need any public. At the other end, your public IP is not free; you have to pay. But the good thing about the public IP, there is internet access. Internet access. You have full internet access by this public IP. So if I go and quickly show me that what is my IP address, and then if I ask you, is it a private or public, then you will tell me. So let me go and check what is my IP address on my laptop. How to check it? Go to the command prompt and run the command IP config, and that's it. So I am connected to the Wi-Fi, right? This is my Wi-Fi port. And on my Wi-Fi port, you can see that my IP1 is IPv6. So leave that. Here is my IPv4. What is my IP? It is 192.168. Something 28.249. So see here, is it a public or a private? If you check this range, 192 and 168. If any IP starting with 192, 168 will be a private IP. Correct? So my IP is a private IP. But if my IP is a private IP, then how I am able to connect with you on Zoom meeting or maybe the Meet, right? Because Zoom and Meet on internet. So if I have my laptop having a private IP, how I'm able to connect on the internet? As I said here, that with private IP address, no internet access. So what is happening here? So the thing is, my Wi-Fi router, from where I'm getting this Wi-Fi connectivity, my Wi-Fi router in a home environment is working basically as a NAT, network address translation device. So what is happening in that? My Wi-Fi router is basically whenever I want to go outside and want to access the internet, my Wi-Fi, which is configured as a NAT device, it is changing my IP, which is a private IP range, into a public IP, and then only sending it to the outside. So something like this. Suppose PC5 want to go outside and get the access of internet server 188.8. So PT 5 society will be something like this. It's something 192.168.2.2 maybe. And the destination IP, I want to go on 180.8.8. This side. So what will happen here? PC5 will send the packet to router 1, router 2 to the router 2, and when router 2 is going to send the packet to the ISP, here on router 2, I will configure a NAT. Will configure a NAT like in our Wi-Fi device because my Wi-Fi is connected to the ISP. So I will configure a NAT. What my NAT device is going to do, my NAT device will change the source IP. It will remove that private IP and it will write its own public IP, which may be 177.1. This way. And then only send to the now internet is getting both the IP as a global. So no problem. You can connect to the internet and the reply will come also from the server. So what happened when the reply packet will go? When your server is replying to your PC5, so the server is going to make a packet with its own IP address as a source IP. Means 180.8.8.8 and the destination will be 170.7.7.1. Correct? Because this is the source IP. This was the source IP because server is getting that someone which having the IP 170.77.1 want to connect me, so I need to reply him. So this is the packet which your server will make and he will reply. It will reach on your router where the NAT is configured. So first thing your router will check, hey, is it NATed or without NAT? So your router will find out the entry in the NAT table that yeah, this IP is a NATed. So again, your NAT router will change this destination IP from the public to the private. Which IP? This IP to the IP. And then send it toward the PC5. And then PC5 will accept it because this IP 2.2 is the PC2 5 IP. So both the time, when the packet you are sending, your NAT device is changing your source IP from private to the public. And when server is replying back to you, you are playing with the destination IP and you are changing the destination IP to the private IP and you are sending it to the. So what your NAT is doing, it is it is converting any private IP address from the inside when they are going to connect on the internet to a public IP. So sorry. When the reply comes, the public IP will be changed into the private IP and the packet will reach. That is the NAT. And that your Wi-Fi device at home is doing. Every time when my mobile or the laptop sending any packet, my Wi-Fi device is getting it and Wi-Fi device is connected to the ISP and my Wi-Fi device is also configured as a NAT. So it is changing my source IP from the private, which is 192 something, from private to the public and sending it to the outside world. When outside world is replying back to my Wi-Fi device will again change that public IP to the private and send it to my mobile, to my laptop. This is the way how this NAT works. And in everywhere you will see that NAT is there. So what is the reason of using a NAT? So basically there are two reasons of using a NAT. One thing is you can save the public IP. We can save public IP. How? So think about a scenario that you have a company, and in your company there are maybe 1,000 staff working on that in that something like this, and all the 1,000 staff are communicating to each other, and they also want to go the outside world. And suppose there is a no net conflict. So what you need? You need 1,000 public IP address for your company, correct? If they want to connect to the outside world. So if you want 1,000 IP address, so how much it will cost you? You know that one public IP address, you have to pay from average $3 to something like $10 per month. Per month you have to pay something like that. $3, $3 to $10, depending on the different countries and the IS. So if there is a 1,000 staff member in your company and you want to provide internet connectivity to all of them, so you have to buy that 1,000 public IP. That will cost you something like 3,000 or the 10,000 US dollars every month. See that just to provide internet connection to your staff member, you are unnecessarily paying 10,000, maximum $10,000 every month. How costly affair it is. Even in the home environment. In a home environment, you have taken internet connection and there are five family members. So for each family member, if you are going to take a public IP, it will cost you something like 50 US dollar at max every month, extra money that you have to pay apart from all the other charges. So this is very costly affair. So what the companies and in a home environment we don't do this way. We are not going to buy this 1,000 IP address if I want to provide internet access to my staff member or in a home environment. What we do, we use a NAT card and we just take a one IP from the ISP because every time when you will connect with the ISP, ISP is going to provide you a one IP as a fee that will be included in your plan. When suppose you are taking a 100 Mbps plan, so obviously in that 100 Mbps plan, they will also add a one public IP address. So you will just take a one internet connection from the ISP and you will use the network. Internally, you will use all over on the devices private IP address. When they want to go and access the internet, you will use the network. So that you are going to save that 1,000 of public IP address in this company. In a home environment, you are going to save five public IP addresses and the money also, right? So the saving the money and saving the public IP address also. So that is the true reason of most of the time, and this is the main reason of using a NAT in any network to save the public IP address as well as the money. Unnecessarily, we should not waste the money. So this is the first thing. Second reason, it might be said that it is because of the security. What is the security reason? You will understand because if you have internally private IP address and all the time your NAT device is translating that source IP to the public and then sending it to the outside world. So the outside world will never know what is your real IP, the private IP. What they will know the IP address of your Wi-Fi router or your gateway router, a public IP. So if anyone on the internet is trying to attack on your device, can it be possible? No way. Because you never know what is the public IP of this PC5 or the PC2 or the server. No, you only have a one IP, which is my gateway or the Wi-Fi router's IP. So you can reach till my that Wi-Fi device. You can never reach toward my PCs, those who have the private IP. So that way, it can help you to secure your network from the outside world if any hacker is trying to attack on your network. So these are the two reasons of using a network. All right. Now, the misunderstanding about the NAT. So I have taken example that how the private IP address is converted by the NAT and then they are accessing the internet. This is a use case. I'm explaining you the use case of the NAT. But it doesn't mean that NAT is basically changing from a private IP to public IP. Don't confuse with that. NAT is not doing that. NAT job is only to convert whatever the source IP is there from one IP to another IP. That's it. Router has no information, or the NAT has no um, reason to understand which is a private IP, which is a public IP. They are just a simple protocol where it is defined that they are converting from one IP to another IP. Yeah, the reason why we are using in this case, we are changing from our private IP to the public, but it doesn't mean that NAT is that. If anyone is asking you to explain the NAT, don't say that NAT is used to convert from private to public IP, because this is the one use case of your NAT, one example of using a NAT. The real thing about the NAT, NAT is basically used to convert from one IP to another IP. Which IP? It might be the source IP, it can be the destination, or it can be the both source and destination. So in the packet, most of the time we use a NAT for changing our source IP. But yeah, we can use it to change the destination IP. That will be called as a conditional NAT that you will learn in the next course, which will be CCNP in the next year. So NAT is basically converting from one IP to another IP. It can change the source IP also. It can convert the destination IP also. But most of the time, where we use the NAT, we use the NAT to change from a private IP, private source IP to the public source IP, just to save the IP address and secure our network. So don't confuse with that. Okay, NAT is basically one protocol which is changing source IP in your packet as well as destination IP in your packet from one IP to another IP. It might be the source, both the private, it might be the both the global IP. So it's not that way. So if sometime if anyone is asking you that can I use a NAT and change from one private IP to another private IP? Yes, we can do that. So they were confused that, oh, I just learned about that NAT is used to change from private to public IP. Don't worry. NAT is basically from changing one IP to another IP. They might be the both private IP, they might be the both public IP, they might be this way also, the private IP to the public. The use case is this. We use it because of saving the IP address space, saving the cost, saving the money, and securing our network. We change our source private IP to the public IP by then. Right? So don't confuse with that. All right. Next thing about NAT. That how many type of NAT we have? Discuss about that. We have basically three type of NAT. Number one is your static. Number two, I'm going to write as a dynamic NAT. Number third is my path, or sometimes we also call it as the overlay. So these are the three type of NAT we have, and all the three NAT are used in a different scenario. It is not just to make the things complicated. We have a three type of NAT. No, because each and every NAT having a different reason of using in your network. So we'll see that. So first, let's see the basic thing about this NAT. The static NAT is basically a manual. You have to configure that manually, and it is basically one IP to one IP, means one to one connect. So if you are using a static NAT, so one private will be converted to the one public IP. So in your company, if you have suppose 1,000 of devices, so you need still 1,000 public IP address. So you can say that in this case, we are not saving any money. We are not saving any public address. So why we are using this static NAT? Correct? If it is a one-to-one conversion, means from one private to the one public IP, it's not saving any IP address. It's not saving any money. So why we use the static NAT? So we'll see that. What is the reason of using a static NAT? It has a very other reason. Instead of saving the money, it has a very other reason. What is that? You may understand by this word that I'm going to write. It's, this is the only NAT which provides two-way communication. It provides two-way communication. Means once I will configure the static NAT, anyone from the outside world can connect to my that device because it is a one-to-one conversion. So that is the extra things we are getting in static NAT. In which case we use, we'll see that. Second is my dynamic NAT. Dynamic NAT means many to few. Means all the IP or the many IP of your private network can be converted into some few IP pool. Means maybe the two, three public IP pool. It's not like one pool. So it's a good one, but it provides only one-way communication. One-way communication. One-way communication means devices from the inside can connect to the outside world, but outside world can never connect to you. Means they can never initiate a connection and they can connect with you. Suppose I configured a dynamic net on my router 2 and PC3 want to connect to the web server. Then yes, PC3 can initiate and it can connect to the server and get the reply. But if server after some time want to connect with the PC3, he cannot initiate from the outside. No way. So this is a one-way connection. Means one-way communication is possible by this. It provides a one-way connectivity to the outside world. Okay. The next is my PAT. PAT or the overload is the most popular NAT protocol. In this PAT, all to one means all my private IP can be converted into the one public IP address and it will work properly. And it is also a one way. Means all my private IP address I can convert into the one public IP address of my this router. And it will work perfectly well. All the devices can get the internet connection. So this is the most efficient, right? Because all private IP converted to the one IP. So I need only one public IP address. So I don't going to waste any money. In the dynamic NAT, I need maybe the two IP or more than two IP. So still I'm giving some money. But in the PAT, I'm only need a one public IP. And it also provide a one-way communication means internal device can initiate a connection to the outside world. Outside world can never initiate a connection and connect to your internal device by using PAT. So dynamic net and PAT is basically providing a security so that anyone from the outside world can never start the connection, can never start the connection to connect your device. But in case of a static NAT, it's a very interesting. Here the two-way communication means outside world can initiate the connection and connect to your device. So in the first case, I'm not saving any money. I'm not saving any IP address. It is one-to-one conversion, right? But in the dynamic case, I'm saving some money because I'm converting my all private IP to the few public IP. In the PAT, I'm saving the most, right? I'm saving the most of IP, public IP address because I need only one public IP address. So this is the best one. So think about now that when my PAT or the overload is the best one, then why we have the dynamic, correct? Because if PAT is used to convert my all private IP into the one IP, then why unnecessarily we have to convert my all private IP to the few public IP and make a pool unnecessary? So the reason is PAT protocol doesn't work with some application. In that case, we have to use a dynamic. We have to use a dynamic because some protocol don't support it over PAT. If you have inside your network, inside your company, some application doesn't work well in your PAT. So in that case, you have to configure the dynamic. If you have no restriction, you have no such kind of a application, then don't use PAT. Then don't use the dynamic NAT. Always use the PAT. That will be a best way. Okay. What is that application? Like VPN, IPsec, kind of a things which don't support it properly on your PAT. In that case, we have to use a dynamic. So that is the reason. And what is the reason of using a static NAT? Something like this. So see that all the three NAT having according to the requirement of your company, we have to configure it. PAT is the best one, but it doesn't mean that we don't need ever the static and dynamic. So still, we may need a dynamic in the case if I have an application which is not supported over the PAT, then I will use dynamic. Where to use the static? In the scenario, suppose you have a web server inside your company, and that web server, like all other devices, it also have a private IP address, something like 3.100. Obviously, if it is a private IP address and you are using a dynamic net and patch, so no one from the outside world can connect to your web server. But you know that web server is the most important part for a company. On the web server, company is going to inform to the customer about the new product, about the new features, and all the new things which is happening in the company. So every company want that their server should be web server should be reachable to all on the internet. Correct? So now how to solve this problem? If it is a private IP address, in that case, we use a static. I will use a one public IP for this my server I'm using a static NAT, something like this. 170, 177, dot, maybe the 4 or the 5, like this. What happened now? Anyone from the outside world, if they want to connect to my web server, they will use public address 170.7.7.4. And my router, because of the static net, will forward the packet toward the web server and they will get the connection. So that is the reason why we have the static net. In the case, if your company having a web server and it is working on a private IP address, in that case, we can use static NAT, one private IP of the server to the one public IP of the server. And because only the static NAT can provide two-way communication, so that's good. Anyone from the outside world can initiate a connection on the public IP. And my gateway router will divert the packet toward the server. And that is the reason of having this. So all the three type of NAT having a different usage. The static is one-to-one in the case when your company have a server on a private IP address and you want to provide the access from the outside world. So you convert your private IP to the one public IP. On here, on your router, not on your server. Server will always have the private IP address. You will make these changes by the static NAT on your router here on the gateway router. Dynamic NAT in the case if I have an application in a company which doesn't work well on the pad, then I will use dynamic. Otherwise, in all the rest scenario, we are going to use patch or the overload all the time because it is the most cost effective and saving all my public IP address. I need just one public IP in this way. In the case of dynamic and patch, it provide a one-way communication. It means devices, those who are internal to my network, they can initiate the connection and establish it. But the devices on the outside world can never start the connection with my device internet. So it provides a security. All right. Now it's done. Now we'll see the how to configure these three type of a NAT one by one. But before I go and configure and show you, let's configure this part, because here I am working with the OSPF on all my three routers. No problem at all. I have to configure this ISP router, configure the IP on this web server and PC, and this link also. Let's do that, starting with my this router. Let me make some changes in my. I will use a switch. Otherwise, I have to decide about two other networks. So I will use a switch here and connect it this way. Connect to that PC on the internet and connect to the web server. So let's quickly configure this interface on my router, which is gigabit 0 platform and 0 platform. I will go on my router 3. This is my ISP router. So I will give the name as ISP. Configure my interface gigabit 01 and it is on 180 network, so 180.8.8. Maybe the first IP. And my network is 24, so it will be this and motion down. Second net interface is my gigabit 0/0 and it is on 170. So configure IP from that. I'll use the second IP here. And here my network is 29. 29 will be what in decimal? 248. Correct? And now shut down. That's it. It is done here. And I will show you that I'm not going to use any routing protocol on my ISP. And in real production network also, when you are taking a connection from the ISP is not going to run any routing protocol with your Wi-Fi device. No way. Don't think that ISP is going to run OSPF, GRP, BGP. No way. When you are just taking a simple broadband connection to the ISP is not going to use any routing protocol with you. So the same scenario will use here. I will not use any routing protocol on my ISP between my gateway router and my ISP. No routing. So what ISP do? ISP basically provide a default route to my Wi-Fi device. So I will use that concept here also on my gateway router. This is my gateway router. I will first configure my this interface, which is going to an ISP and this gigabit goes back to it down. and then I will configure the address 170.10.10.1 and then 3 times 255.8, and that's it. Because this is my gateway router, like my Wi-Fi device in the home, I will just configure a default. And you know how to configure a default static root. It is 0.0.0.0 means any network, 0.0.0.0 any mask. If I want to reach anywhere, I will send the packet to the ISP. So what is the IP address of ISP? It is 170.7.7.3. So this static root I configured on my gateway router here in the company mode. Means if it is a company scenario, you will configure this for the static. But in a home environment, we never configure even the static root. Why? Because my ISP is going to provide a default automatically. How? By the DSCP service. ISP will work as the DSCP and it will provide me a one public IP. It will provide me a default gateway. It will provide me the subnet mask and the DNS server. All things my ISP will provide automatically to my Wi-Fi device. So nothing is required to configure on your Wi-Fi device. But in company side, when you have a router, proper router device, then you have to configure the static list. All right. All right. There is one more problem here in this scenario. Let me first quickly configure my server and PC, and then we'll see what is that problem. I will give one IP from this range, 180.8.8. Maybe the 4, it is PC number 4. And the mask, I will keep it as a 3 times 255.0. And the gateway will be the router's IP address, which is 8.8.4. Same way on my server, I will give an IP address 188.8.8.8. So 180.8.8.8. Subnet mask 180.8.8.8. Subnet mask will be 3 times 255.0. And the gateway will be 180.8.8.1, which is the router IP address here on the screen. It's done. There is a one problem. My gateway router, which is a router 2, where I'm going to configure my NAT, he knows how to reach on the outside world and connect to the all world. So these PC can connect. If I configure a NAT here, these PC can connect to the internet and they can get the internet connection. Right now, they cannot get that. Why? Because my PC3, PC4, all are going to send the packet to the gateway. Gateway will send to the ISP. But ISP will say that you have a private IP. So I will not provide the connectivity with this. It will be dropped by ISP itself. Okay. But once I will configure the NAT, these device, this section will get the internet connection, but not this section and this section. Why? Because router 1 has a no default route. Router 0 has a no default. They don't have. So how they can get that? So let's go here and check that. What routing table I have on my router 0. If I go and show you, so IP root, they have the other OSPF route, but no default route. Gateway of last resort is not set, means there's no default gateway. So there are two ways. I can set that if I want to reach the internet, I will send my all packet to the R1. I can configure a default setting. Same way on R1, I can say if I want to reach on internet, I will send my packet to the gateway route. So this I can do. Or I have one other option that is called default information originate in OSPF. Because in my all router, I'm using OSPF configuration. So I can go under my OSPF like this way router OSPF then and I can write the command default information originate. This command is going to propagate my this default route to the all internal device, to the R1 and R2 automatically. So I can configure this, right? Under my OSPF domain, default information originate. And it will send my default route to the R1 and R0 also. And if I go now and check that, they will definitely have a default. See that? They have now the default. Gateway of last resort is set. For the network 00 means a default. Router 0 also has, now router 1 also has. They both will have the default route because of OSPF. And this feature is available only in your OSPF. So they all have it. Correct? Here also. So on set, this is how a network is configured for a company, a small company. They have their routing protocol is done. They have the default route. All they are working on a private IP address. And here is your internet. Right now, any PC, if they will try to get the access of server or the PC, they will not be able to connect on the internet. Why? Because they have the private IP address. And private IP address is not understood by your internet. If I go and show you the routing table of your ISP, you can see here what your ISP know. ISP knows only public IP, 170 or 180. It doesn't understand your private IP. It's not going to treat it. It's going to drop the plan. So let's see that. Can I get that connectivity or not? So if I go on any PC and check it by the ping ICMP command, this command to test the connectivity with any device like this, I will not be able to do. No way. Even if I try from this side, which is directly connected to the gateway and going outside, they will never get the internet connectivity. And the problem is your private IP address. When ISP is getting the private IP address, ISP has no idea where I need to send this packet. So it will drop the packet. So 180.8.8. No connectivity. Right? And the reason is ISP. ISP don't understand our private IP address. It's going to drop the packet. So I can solve this problem. We can solve this problem now with the help of NAT because my this router having a one public IP address. So first of all, I will show you the patch, how to configure a patch. So let's see that. What things required to configure a patch? Number one, I need an access list. For what? To match my private IP address. Means which IP I want to convert into the public IP address. Correct? I need to know that. Means I have these private IP 3.0, 2.0, 1.0. I want to convert these all private IP to the public IP when they are going to connect on the internet. So I need to use the access list and I will map my all private IP address inside my network. This is the first step. Second step is your configure the direction. Direction means what is your inside and what is your outside. It means because you know that your dynamic and pat is working in a one way. Means if anyone from the company want to go to the outside, then my conversion will happen. If anyone from the outside coming to my internal, then no NAT will happen. So, but how my router will understand which is the inside of my company and which is the outside of my company? We human being have the eyes. We can see that. This is my internal network and this is my outside network. Correct? But routers will never understand that. So I need to tell my router that, hey, my gigabit 0/0 is the inside. My gigabit 0/1 is my inside. And gigabit 0/2, which is going toward the ISP, is the outside. So I need to define it on my all interface of the gateway router, which is my internal network of the company, and which interface is going toward the ISP. So I will define a direction. Last thing I need this. Only three things is required to configure access list to match my all private IP address of the network. Direction is required because the router will never understand which is the inside of your network and which is the outside of your network. So I need to define it on each interface. Third thing is my NAT tool. Whatever I will configure as a pack that I need to configure here. Once I will do that three things, all set. All the devices will be able to connect to the internet. So let's see that one by one, all these three things, how to configure NAT rule, how to configure my direction inside outside, and how to configure access. So as I said, that I'm going to configure the NAT on the gateway router. And always remember that most of the time you will configure your NAT on the gateway router, which is going toward the outside world, toward the IS, not on the internal. So I need to know that to whom I want to provide internet connection. So I want to provide any devices, those who are on 1.0 network, those who are on 2.0 network, those who are on 3.0. So I will match that with the help of access. So which access list I will use? I will just configure a normal standard access. So let's see that how to configure it. Access list, write a number from 1 to 99 and then 10. So I'll write the word permit. Which IP? My all these three networks 1.0, 2.0, and 3.0. So I will call all that one by one, like this way. 1.0, wildcard will be 255, then my 2.0, 2.0, then my 3.0. The permit statement meaning here is it's not basically to allow or deny something. This is basically here in the case of NAT, it is matching my three network 1.0, 2.0, and 3.0. So you can say that access list 10 is basically having three IP range 1.0, 2.0, and that is the only role of this access list. I'm not going to apply this access list on my interface to do the packet filtering. No, I'm going to use this access list to perform my NAT job, to translate my private IP to the public. Okay, so I'm matching my all private IP address with this. Now I will define which direction is inside, which direction is outside. So 00 is going toward my company. 01 is going toward my company. So these both are my inside. 0.0 and I will write IP NAT inside. Same way my interface 0/1 is IP NAT inside. And my 0/2, which is going toward ISP, will be IP NAT. Then the two things we have. We define an access list number 10 to match my all private IP. We define the direction. Now the time to configure the NAT tool. Let's see that how to configure the NAT path tool. The command is IP NAT inside source list. What is my access list number? 10. And interface gigabit 0/2 and the word over. Now, before I hitting the enter, I will tell you the meaning of each and every word here, one by one. Let's see that. IPNet inside, it means I'm instructing to my gateway router that, hey, if anything is coming on the inside interface on 00 or on 01, check the source IP. And if the source IP is from this range, access is 10 range, then 1.0, 2.0, or 3.0. Change that source IP to this public IP. Which public IP? Whatever the IP you have assigned on 0.2, that public IP. And do the overload. Means path. Listen it again. IP NAT inside, I'm instructing to my router, check that any packet is coming on the inside interface and they want to go on outside interface, then check their source IP. And if their source IP is according to the access list 10, then change that source IP in the packet to the public IP of this interface. That is the net. That's it. We did that all three things. Let me revise it again. First of all, we configure a access list to match my all private IP addresses in my network. Just to match. Second thing, write down which interface is toward my internal network and which interface is going toward my outside. And then at the last, I'm defining my patch rule. Patch rule is this: IP NAT inside, if packet is coming on my 00 or 01 port, my means inside port, then check the source IP. And if the source IP in the packet is from the access list 10, then change that source IP to the public IP of this interface. That's it. So understanding the meaning of command is very, very important. Understand means learning the command or memorizing the command is not going to help you at all. The concept behind this command, all right, everything is done. If my NAT is configured properly, the path is configured properly according to these three steps, I will be able to connect to any device on the internet. Let's check it quickly from the PC. First few packets will drop because of the ARP request, but after that, I will get the reply if NAT is configured properly. The reason is I have already configured, I think in the previous class, access list. So let's check that. Do I have access list? Yes, I have. So I will delete that access list. Check that. Is there any more access list? Space more. Away. Let it be in the configuration. That's not creating any problem. If access list is not applied on the interface, then it will not create a problem. Let's check it here also on my this router. Is there any access list? No way. Now let's try. The problem, let's check it from this PC5, and then we'll come back again to that PC0. Why is not affected? First, I need to verify whether my NAT is working properly or not. So, yep, see that here it is working on 5. Same way, I will test it from this side also, from the PC3. Yes, it is working. Now they are able to connect. Why it's not working? Because the IP is not configured, I think, or the IP is wrong on this PC1. Let's try from the PC1. Yes, they are getting it. The PC0 might be having the wrong IP or something else just like that. Is there any problem? 1.2, 1.1, that is correct. So we should also get that. So it's not getting. Let's check that whether it can reach to the default gateway, which is 1.1. Yes, he is able to reach that. He is able to reach that 3.1. He is able to reach there. So why he is not able to reach on this 180.8.8? So let's check that. Might be this PC is not working, but yeah, PC1 here in this network, PC5, PC3, they all are getting the internet access. It means my NAT is working properly. How to verify that? If I go inside my this router and show you the command, so I can NAT translation, you will see that the translation is happening for my source IP. See that? My source IP 1.10 is changed to this public IP. If I start as a more connection, continuous connection from this, so I will get that as well. 55, 63. So I will see the more conversion. See that. PC 3.2 is also connected to the same global IP, 170.7.1. PC 2.3 is also converted to the same IP, 170.7.1. So this is where you can verify that your NAT is working properly or not. So now, what is the meaning of these four terms? What is the four words? Inside local, inside global, outside local, outside global. So inside local means my source IP in the packet before NAT. So yep, this is my source IP before the NAT. Inside global means my source IP after the NAT. So yes, after the NAT, all the source IP will be changed to the one public IP, 170.7.1. So this is clear. What is inside global? What is inside local? Inside local means my source IP in the packet before NAT. My source IP after the NAT is inside global. Outside local and outside global is what? Outside local, outside global is about your destination IP in the packet. So I'm not playing with the destination. So before the NAT is my destination same. After the NAT, my destination IP is same. So I'm not playing with my destination. I'm not changing. So from here, you can understand that NAT can be used to change both IP, the source IP as well as destination IP. Correct? It can be used to translate both the IP, but I'm using it only to translate my source IP to the public IP. So this way you can check it out. Okay. Tell me one thing. Everything means all is working well properly here. PC1, PC5, PC3, they all will be able to connect that. But if these PC will try to connect with your internal device, can they connect? No way. If I try from this PC4 to access your internal device, which is 192.168.3.2, I will never be able to connect that. Or maybe the 2.2, I will not be able to connect. If I try with the 1.10, which is this IP, I will not be able to connect. So anyone from the outside, they are not able to connect. But when my PCs are trying, they can connect. So what is the IP of PC4? It is 8.8.4. If I check it, I will be able to connect with that 8.4. See that? But the PC4 is not able to connect my IP. So this is a security, and basically it also clear that paths can be used to provide a one-way communication. So means only internal device can initiate the communication, then the real communication happens between the two devices. If outside world is trying to initiate or they start the connection, then my pad or the dynamic NAT will never allow. So this is all about your dynamic NAT, your patch or the overload. One thing is left. Let me ask you. PC1 is sending, I need to do this. Source IP is here nowadays. 2.2. Destination IP, I want to connect with the server, 192.2.8. This PC is generating that. This PC3 also making a one packet and want to connect with that. PC3 IP is here is 3. They both are sending the packet where they will send this packet to the NAT. NAT is going to change the source IP. NAT is going to change the source IP to its own IP. What is that? 170.1.1 and send it toward the outside, toward the server. Same way, when PC3 will send a packet, my source IP will be changed. It will be the public IP 172.1.1. This is also sending a here as well. Now, when my server will reply, what will happen for both the packets? My source IP will become the 80.8.8 and the destination will become in both the case 170.7.1. Correct? In both the cases for both the packets. Yeah, it is there that PC5 one packet send, one packet PC3 send. But my server is getting only that IP 170. So obviously it will send a destination will be the same. So let's change it now. My source IP will be the server IP and destination IP will be 170. in this packet and also in the lower packet, which is from other place. This way. Now both the packet will reach here on my NAT gateway router. How my router 2 or the gateway router will understand that this packet is for PC5 and this packet is for PC3, because both having the same destination IP address. Correct? It is very confusing for the router 2. How to understand that which packet should go to the PC3 and which packet should go to the PC5? It will totally confuse because they have the both same destination IP, which is its own public IP. It will check the translation. It will find out that I changed that 2.2 into this IP and 3.2 also to this IP. But I am totally confused now. Which IP, which packet should go to here and which packet should go to here. So how your router will solve this problem? Yeah, it will keep the, yeah, definitely. It will keep the log that this IP 3.2 is converted to this IP, 3.3 IP is converted to this IP. But in both the cases, private IP is different, but the destination is the same, 70.7.1. So how my router will be understanding? So answer is here. When my router 3 is making a conversion for this private IP to the same public IP, see that all public IP is same and the source is different. So what my router is doing, he is also using a one port number. You see that? Port number. And then mapping it with that port. So all the time when my router is converting in a PAT case, where I'm changing all my private IP to the one IP, it is also mapping the port number. So that when the return packet is coming, my router will not check the destination IP. It will check also that, hey, what is the destination port? If it is 10, then I will send it to this device. If it is 12, then I will send it to this device. If it is 5, 177.7.15, then I will send it to the 2.3. So what my router is doing in the path, it is not only changing the IP, it is also mapping the port, source port to the destination. So that when reply packet come, it will check the port number. And then only my router will be able to understand that the packet which I am receiving with the same destination IP, it should go to the PC5 or it should go to the PC3. That is why we call it as a PAT, means port over translation. We are also translating our port, source port to another source. I can keep it as a same or I can keep it as a different. But by default, your source port will be changed to the same source port. See that 10 is changing, 10 port number is changing to the 10 port number same after the NAT, right? So this is the way how your router will differentiate when it will receive the packet from the server and they all having the same IP by the port number. That's why this NATing is called as a port address translation. You are not only translating your source IP, also you are changing the port, translating the port. Clear? All right. So now we are left with the dynamic and the static. So let's take a break. It's just a 1 hour, but yeah, let's take a break and we'll see both static and dynamic after that. Okay, in 20 minutes. Yeah, stop this room recording.